Okay, what we have here is a composition of functions problem, and I've got f of x, which is 1 over 2 minus x, and I've got g of x, which is 1 over x squared. And what I'm to find is f of g of x in the domain of f of g of x. And that's usually pretty simple for most students to find. Because all you do is you just stick g of x inside of f of x, and that's usually fairly simple, and then you simplify the result. Most students have trouble with this domain, though. This is tricky. And there's a nice little trick you can use to find that. But let's start out with finding f of g of x, and what I have to do is I have to put this 1 over x squared right in here, right into x. So I've got f of g of x, and what does that equal? That equals 1 over 2 minus 1 over x, and that's a square there, x squared. Okay, you can read that okay, all right? And then we simplify it, and of course we add these two fractions, right? So we end up with 1 over 2x squared minus 1 over x squared, and this is the long line, right? And that, in the end, equals x squared, I'll put it right here, x squared over 2x squared minus 1. And that is our f of g of x in its simplest form. However, it's not really obvious from this final form what the domain really is. You have to do a little bit of work, and usually the explanations in the book are fairly complicated. They get involved with the idea you have to find what values of x will work in this function, and then what the range is and what parts of the range won't work in this function, etc. And although those are good explanations and they should be read and understood, students have trouble with that. But there's actually a fairly easy way to do this. And the easy way to find the domain of f of g of x is not look at this, but look at the point where you first put g inside of f. And this is fairly easy to analyze, and I'm going to erase all this. In fact, I'm going to erase, well, I don't want to do that. I want to keep g of x equals 1 over x squared up there. But I'm going to erase all this. You could stop it and copy it down beforehand. I need the room here. So I'm really going to look at f of g of x as 1 over 2 minus 1 over x squared. In other words, I'm going to look at it at this point, not when I actually end up simplifying. At this point, I see two things. I look at the denominators. I have two denominators. I have a denominator in this fraction, and clearly you can't put 0 in there. In other words, x squared cannot equal 0. Cannot equal 0, which implies that x cannot equal 0. Okay? And so x can't equal 0, and also we have this other denominator right here, which is kind of lost when you simplify it. I think it's kind of hard to see that. And we end up with 2 minus 1 over x squared cannot equal 0 either. So we have this part of the domain, x can't equal 0, and then we have this part of the domain. In order to find out what x can't be here, we multiply both sides by x squared, and when we do that, we'll get 2x squared. I'm going to say implies, I'm sorry. 2x squared, minus 1 equals 0, cannot equal 0. Right? We multiply both sides by x squared. And we find that when we solve for that, we will get x squared cannot equal 1/2, which implies that x cannot equal plus or minus the square root of 1/2. Because if it does, it won't be in the domain. It won't be in the domain of this function right here, which is the same as the simplified function at every point, except that it can't equal those numbers. So we end up with this domain. And again, I'm going to erase this again. Okay, if you want to stop the video and write that down. And I'm going to write our final answer, which is the domain of f of g of x. Okay, is all x, such that x cannot equal 0, otherwise it won't work. Okay, it's not in the natural domain of the function. And x cannot equal plus or minus the square root of 1/2. Okay, and that's our domain, which you wouldn't have gotten from the simplified function.